Okay, let's move to the next part. This is a kind of interesting one, which is number systems. In number systems, actually, so I think last day also we have discussed, but in case if I miss, let me repeat from the beginning. So then all of you can understand and go through this. So here in number systems, actually, so we will be learning about decimal, binary, octal, and hexadecimal. It's very important because even though this lesson is number systems, we are going to use these number systems in HTML and in graphic part, in networking part. We are going to use the same number system. So it's very important to remember these number systems. So let me explain this quickly. Base 10 decimal number system, the high පාදේ සංඛ්‍යා නැත්නම් base 10, you have 0 to 9. 0 1 2 3 4, these are the digits, and actually range is 0 to base minus 1. 0 to base minus 1 is 10 minus 1, it is 10. Then this is an example, 7832324, and this 7 is called most significant digit. So if you don't know, please write down. MSD means most significant digit. It has the highest value and it is the leftmost digit. Leftmost digit. වම් පැත්තේම තියෙන digit එක තමයි most significant. Most significant කියන්නේ වැඩිම අගයක් තියෙන digit එක. ඒක වම් පැත්තේ තියෙන ඉඳ අපි කියනවා leftmost digit කියලා. LMD කියන්නේ leftmost digit. MSD කියන්නේ most significant digit. And the right side you have rightmost digit, RMD. Rightmost digit, this one, and that is least significant digit. It has least value. අඩුම value එක තියෙන මේ පැත්ත. Least significant digit. And how we are going to represent, let's say this 2 මෙතනින් එහාට ධන සංඛ්‍යා නැත්නම් පූර්ණ සංඛ්‍යා ටික අපි පෙන්නන්නේ base to the power 0. Base to the power 0. 10 to the power 0, 10 to the power 1, 10 to the power 2, and 10 to the power 3. 10 to the power 0, any number to power 0 it's 1. Any number to its power 1 is the same number. Any base to its power 1 is same number. 10 to the power 2 is 10 into 10, 100. 10 to the power 3 is 10 into 10 into 10. That is 1000. So then, the other hand, you have here, for decimal side, you have negative values. 10 to the power minus 1, that 1 divided by 10, 10 to the power minus 2, 1 divided by 100, or 10 to the power minus 3, 1 divided by 1000. These are the values, 0.1, 0.01, and 0.001. Similar to that, in binary number, you have 1 and 0. Here you have 2 to the power. 2 to the power 0 to 2 to the power 3, 2 to the power 0 to 2 to the power minus 3, other side, minus 1 to minus 3 or 0 to 3. Then here you can see 10 times. එක 10 ගුණයක් වුණාම තමයි 10. 10 10 ගුණයක් වුණාම තමයි 100. But here in base 2 you can see 2 times. 1, 2 times of 1 is 2, 2 times of 2 is 4, 2 times of 4 is 8. මේ පැත්තට දෙගුණ වෙනවා. මේ පැත්තට භාගයක් වෙනවා. මේකේ මේ පැත්තට 10 ගුණයක් වෙනවා. මේ පැත්තට 10න් එකක් වෙනවා. 10 times 1 divided by 10 when it comes to this side. So here multiply by 2, divide by 2 when it comes to this side. 8 divided by 2 is 4, 4 divided by 2 is 2, 2 divided by 2 is 1, 1 divided by 2 is 0.5, 0.5 divided by 2 is 2.5, and 125. Likewise, in octal you have base 8. Octal you have base 8, 8 to the power 0, and it is increasing. Here it is decreasing. Then here 8 times 1 is 8, 8 times 8 is 64, 64 times 8 is 512. So the other hand, it's minus 1, minus 2, minus 3. In hexadecimal, you have, right, in hexadecimal number system, base 16, and it is from 0 to 15. When you are writing 0 to 15, you write like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. After that, 10 is A. Why we are not going to write 10 here? Because if you are going to write 10 here, it is reusing of 1 and 0. Here, 1, 0 is you reuse. So to stop that, to avoid that confusion, we are using A. A, B, C, D, E, F. 15 is F. After that, you don't have. You don't have G, H, I, J, K, L. No. Only up to F. So then again the same thing. So power increases this side, power decreases this side, and here 1 into 16, 16, 16 into 16, 256, 256 to 16 is 4096. Okay, that's how you have the number system. Now, let's start the work. So now you have listened. Now I need you to work actually. So this is not like listening. You have to answer using chat section. Please use the chat section to answer these questions. So I'll give you the questions. So what you have to do is you have to calculate and find the answer. Let's see who's going to find the answer first. I'm going to give you few numbers. Okay. First example. My first example. Let's convert decimal to binary, octal, and hexadecimal. So that is my question. Convert decimal to binary, octal, and hexadecimal. So the first number is 25. The second number is, let's say, 127.875. That is also base 10. Right? This is also base 10. So the next one, you have 2048.3125. Again base 10. 2048.3125. That is base 10. Then next one, 0.5 in octal. Right, then next one, a 0.9 in hexa. Let's say a 8.9, a 8.9, a 8.9 from hexa. So these are the numbers. What you have to do is you have to convert these numbers to binary, octal, and hexadecimal. Some of you have done this already? No, it seems no. Okay, let's start. I'll explain the first one. I'll explain this using two numbers. My example. Example number one. Assume that you have 19 in decimal number system. You want to convert this to binary. So how you are going to convert this? You have to divide this number. First, divide this number by base. Divide by base. Then write the remainder. Repeat. Repeat until all digits are in all digits. Repeat until all digits are in intended base. යාදාලා බේස් එකට ඔක්කොම ඩිජිට් තියෙනකම් මේක කරන්න ඕන. Okay, let's do this quickly. 19 divided by 2, then you know 19 divided by 2 is 9 remainder 9 and remainder, let's write remainder like this, remainder 1, because 9 into 2 is 18, then remainder 1, remainder make a purna සංඛ්‍යාත්මකව තමයි ගන්න ඕනේ. You have to tell the integer value. Don't write 19 divided by 2 is 9.5. Then you are not going to do this. එක එහෙම කරොත් උත්තරේ හොයන්න බෑ. පූර්ණ සංඛ්‍යාත්මක තමයි ගන්න ඕනේ. Think about there are 19 marks. Okay, think there are 19 marks or 19 caps. You have 19 hats or caps. You are going to divide between two people. Then one will get 9 because you can't give half hat, half bhagyak denna bane, half hat or half mug, or you can't give like that. So one will get 9 caps. One will get 9 caps. The second one will also get 9 cap, and there will be one remainder because you can't divide that to these two because you can't give halves. Then 9 divided by 2, it is 4 remainder 1. Okay, 9 remainder 1. 9 divided by 2 is 4 remainder 1. 4 divided by 2, it is 2 remainder 0. Then you take 2 divided by 2. It is 1. 2 divided by 2 is equal to 1. Remainder is 0. Then you have to take from bottom to top. Then you can see all digits are now in binary. Binary means ones and zeros. Binary wala tiyenne ones and zeros. It supports ones and zeros. So now all digits are in ones and zeros. Let's highlight these digits. All are in ones and zeros. You have to take from bottom to top. And when you are writing bottom to top, the value of this will be 10011, that is in base 2. So you have to do the same thing when converting to base 8. Attempt base 8 octal current. When you are converting to hexadecimal, divide by 16. Okay, what happens if you have a decimal number? What happens if you have a decimal number? Like this, 19.87, or let's say 19.625. 19.625. So how we are going to do this? So 19 you apply the same method. 19 you have to apply the same method and divide these numbers. Apply the same method. But for 0.5, there's a separate method, 0.625. You have to write 0.625 separately. Then multiply it by 2. What is the value? Can anyone tell? 0.625 multiplied by 2. What is the value? I need answers now. දශම 6 2 5 දෙකෙන් වැඩි කරාම කීයද? Yes? Are you there? Okay, quickly do that and tell me the number. 0.625 into 2 is? Yes? Let me?
1.25.
1.25, yeah. 1.25. You have to write that 1.25. Then you have to take the point part again, 1.25. Then take that point part again. I'm going to write this like this. I'm going to have a pipe mark here. Here also I'm going to have a pipe mark. This is our 0.25. Again, multiply by 2. What's the value? 0.25 multiplied by 2. It is? Now you have to answer 0.5, no? 0.5. 0.25 into, so you are not going to multiply 1.25, okay? 0.625, it is 1.25. Then 0.65, it is 0.5. Then 0.5 multiply by 2 is, yes? 0.5 into 2. Yes? Tell me. Okay, let me again. 0.5 into 2 is 1.0. It's 1.0. 1.0. When you get 0, you have to stop. When you get 0, you have to stop. Now you have to take from top to bottom. Let me highlight this in green color. You have to take from top to bottom. This way. First, you have taken from bottom to top. Let me draw an arrow. This you started from this direction. You went from bottom to top. Okay, bottom to top. But the next one, you have to go from top to bottom. Here, this one you have to take from top to bottom. The other way. This way. Then what is the value? Okay. 10011 0.101. You take from this side 10011.101. That is the binary value of this one. So if there's a whole number or integer, you just divide by 2 and write the remainder. If it is fractional number, you take the integer part and do the same, and take the fractional part and multiply it by 2. Understood? Okay, now actually,
Can you explain it again?
yeah, I can explain it again. Purna සංඛ්‍යාවක් නම්, if it is a integer number, you can divide by the base. Then දෙකේ පාදයටනේ හරවන්නේ. Divide by the base. 19 divided by 2 is 9 remainder 1. 9 divided by 2 is 4 remainder 1. 4 divided by 2 is 2 remainder 0. 2 divided by 2 is 1 remainder 0. Until all digits are in the particular base. සියලුම digit දෙකේ පාදේ වෙන්න ඕන. දෙකේ පාදේ digits මොනවද මම කලින් කිව්වා. 0.1යි. දෙකේ පාදේ digits ඕනම් මතක තියාගන්න මේක එක පාදේ තියෙන digits මොනවද? දෙකේ පාදේ 0.1. 0 and 1 belongs to base 2. 0 1 2 3 4 5 6 7 belongs to octal. 0 1 2 3 4 5 6 7 8 9 belongs to decimal. Then 0 1 2 3 4 5 6 7 8 9 and A B C D E F belongs to hexadecimal up to 15. These are the digits valid in the particular number system. So here binaries, all digits are valid in binary number system 0 and 1 because you are going to convert this to base 2. Then you have to divide by base and write the remainder. Base එකෙන් බෙදලා ඉතිරිය ලියන්න ඕන. මේකත් එහෙමනේ. Divide by base and write the remainder. හැබැයි මේ පූර්ණ සංඛ්‍යා පැත්ත විතරයි. දශම සංඛ්‍යා පැත්ත බේස් එකෙන් වැඩි කරන්න ඕන. බේස් එක මොකක්ද? Base is 2. එතකොට දශම 6 2යි 5 දෙකෙන් වැඩි කරනවා. Multiply by 2 it is 1.25. ඊළඟ දශම 2යි 5 1.25 නෙවෙයි. දශම 2යි 5 දෙකෙන් වැඩි කරනවා. 0.5. දශම 5 දෙකෙන් වැඩි කරනවා. 1.0. ඒකල උඩ ඉඳන් පල්ලෙහාට ගන්න. මෙතනදී පල්ලෙහා ඉඳන් උඩට ගන්න. එහෙම අරගෙන අපිට මුළු සංඛ්‍යාවම හොයන්න පුළුවන්. මුළු සංඛ්‍යාව එතකොට එන්නේ 1.0.1.1 දශම 1.1 මේ පැත්තට. මෙහෙම ගියා පල්ලෙහාට ආවා. ඒ විදිහට තමයි දශම සංඛ්‍යාවක් තිබ්බොත් හොයන්නේ. Okay, now you have some examples. So today actually we will do another 15 minutes. So don't worry. So we will not finish by 8 now. So we will be finishing by within next 15 minutes. So please do this. Can you do 25 and tell me the answer? After you complete, I'll do that. So ඔයාලා කරන්න කරාට පස්සේ මමත් කරනවා. 25. Can you convert to binary? And can you convert to octal? And can you convert to hexadecimal quickly? And tell me the answer. තනියෙන් කරන්න බලන්න. So others can also see this. 25. 25. Let's divide it by 2. Then 12 remainder will be 25 divided by 2 is 12 remainder 1. 12 ඉතිරි 1. Then again divide by 2, that is 12. 12 divided by 2 is 6 remainder 0. Then again divide by 2. 6 divided by 2 is 3 remainder 0. Again divide by, that is 3. Sorry. 3 divided by 2 is 1 remainder 1. So you are going to write from bottom to top. The value will be 11001 in binary. 1101 in binary. So that is correct. I think all of you have done it correctly. So then what about octal? That's the thing. That's you have to think. Octal 25. Same 25. You have to divide by 8 now. Divide by 8. 25ට 8 ඒවා. So there are how many fours? How many? 3 altogether. 3. The remainder is, yeah, it's 24. 24 නේ 25ට 8 ඒවා 3යි කියන්නේ 3 වරක් 4නේ. 3 වරක් 3 sorry 3 වරක් 8නේ. 3 වරක් 8 24යි ඉතිරි 1යි. So balance is 1. So 25 divided by 2, 3 remainder 1. Then 3 and 1 both are belongs to, you can see 3 and 1 both are belongs to 3, 1 both are belongs to octal. So no need to calculate again. You take from here, you take like this. this direction and then up. No need to go up actually because it's very small one. No need to climb the ladder. No need to go up. So value will be 31 in octal. It's very simple. 31 in octal. So next one. Next one is hexadecimal. 25 divided by 16. You have only 1 equal to 1. Remainder is, balance is 9. Again, same thing. No need to go up. 1 and 9 both are in, 1 and 9 both are in hexadecimal number system. Therefore, you write like, okay, the answer for this one is, I'm going to write this in front of this, 19 in base 16. That's how you're going to write 19 in base 16. Okay, then I think all three answers correct. 1, 1. So let's check the answers that you have sent. Yes, you have sent 1, 1, 0, 0, 1 is correct. It was 31 is correct in octal. 19 is also correct in hexadecimal. Let's do this one. Let's do this one quickly, and then I can understand whether you understood the concept or not. Both this one and this one, both 2 and 3. Quickly do this both 2 and 3.